Hi Andy, good morning. This is again Dr. C.H. Kiran Kumar dealing you the machine learning part, and now we are in the almost last topic of tree models, that is regression trees and regression. The terminology of regression tree I already discussed. Again, leaf node, decision node, child node, parent node, you all might be knowing is how to construct a regression tree. Initially, all records in the training set are grouped into the same partition. The algorithm then begins allocating the data into first two partitions or branches using every possible binary split on every field. So this is how we can construct a regression tree. Now pruning is applied. Advantages of regression trees. Now how do we do actually? Let us see an example here, my dear friends. Let us see an example. Now here B3, there is only one instance of B3. T02, we have 1, 2, 3, 3. They are 2, 4, and 7. Similarly, A100, if you say 3, 6, 8. So these are all some example. Let us see how to solve this problem, right? Now, if you see here, A100, no, there are only 5 instances. 1, 2, 3, 4, and 5. Distinct models are 5. So we have written the 5 models. And A100 has 3 instances. We have written the 3 instances. And B3 has got only 1 instance. E12 has got only 1 instance. And M102 is having only 1 instance. T202 is having 3 instances. We have written the price as target variable, and we have written that price here. Now, in the same way, if you say condition, there are only 3 conditions: excellent, fair, and good. So we have excellent, good, fair. Now, excellent, how many excellent rows are there? This is excellent row. This is again excellent row. For this, 4, 5, 1, 3, 1, 7, 7, 0. So we have written 4, 5, 1, 7, 7, 0, 4, 5, 1, 3. How many goods are there? 1, 2, 3, 4. 1, 2, 3, 4. So there are 4, similarly 4 variables, 4 values. There are fair means there are 3, 1, 2, 3. So what are the fairs? 625 and then 99, 79. So 77, 99, 625. 77, 99, 625. Similarly, less like yes, no. How many S are there? 1, 2, 3. 3S, 625, 870, and 1900. 625, 870, 1900. Similarly, the remaining has been written here. Now, let us calculate the weighted average, and let us calculate the distance, variable distance, and all. Let us see this. How do we calculate this? See, the means of the first split. The means of the first split are 1574. What do you mean by means? Means and mean and so the mean of this is 1574. The mean. So the mean, there is only one item property. The mean of this is 4513. The mean of this would be 77. The mean of this is 870. The mean of this would be around 300, something like this. See, 1574, 4513, 77, 870, and 331. So this is the means. And the weighted average of the squared means is 3.21 into 10 power 6. How it is calculated? This is just mean lo nunchi teesivesi. See, this is how it is calculated. You have to deduct each one. ప్రతి దాంట్లో నుంచి మీనుని తీసి దాన్ని స్క్వేర్ చేసి వాటిని సమ్ చేయాలి. So this is called variance, my dear friends. This is how the weighted average is calculated. The weighted average is called. Similarly, the means of the second split are 3142, 1023, and 267. Second split means this is second split. This is second split. So the mean is the mean. Similarly, third split. This is one mean, this is second mean. So మూడు స్ప్లిట్లకి see means రాసుకున్నాం and weighted average కూడా calculate చేసాం. It is 2.68 into 10 power 6. And for the third split, the means are 1132 and 1297. With the weighted average squared means 1.55 into 10 power 6 square means. We therefore branch on model at the top level. This is model మీద jump అవుతాం because this is weighted average squared means kabatti and distance kabatti distance. So this gives us 3 single instant leaves ante like as well as 3 A100s and 3 202s. For A100 we obtain the see this would be our model. So this is A100, this is B3 final, this is final, this is final because there is no branches for this. And when we come to A100 and 202, we have to check what is that we can do. We have to check. See this. Now for A100s we obtain the following splits. Condition is excellent. Less lie is two conditions. Again you have to calculate in the same way. You find the mean of the first split, find the mean of the second split, and find the weighted average of the squared means, and then you come to a conclusion that less lie is a better one. So automatically, without going through the calculations, we can see that the second split results in less variance to set. So for 202 splits are as follows. See the 202 splits. This is we have initially calculated A100s. Similarly, 202 splits also have to be calculated, and the final regression tree would be like this. So there is no need of condition at all. Fair, good, not at all required. This is called construction of regression tree. My dear friends, regression tree. Hope this is called regression tree. Now, the next topic we are going to discuss is clustering trees. See, normally regression and cluster, they are entirely two different things. And regression comes under supervised learning, and clustering comes under unsupervised learning. But see, cluster analysis is the assignment of a set of observations into subsets, so that observations in the same cluster are similar to in some sense. See, oka chota unna anni cluster ante clustering cheyatam, clusters ga divide cheyi ante enti one hierarchy, one set is similar in this particular point. For example, you take all red fruits or yellow fruits, something like this. Mango, all mangoes will come red, green అన్నారు అనుకో. సో జామకాయలు లేకపోతే ఇంకా అట్లా గ్రీన్ కలర్ ఉన్నాయన్నీ ఒక సెట్. దట్ ఈస్ కాల్డ్ క్లస్టరింగ్, మై డియర్ ఫ్రెండ్స్. రైట్. క్లస్టర్ అనాలిసిస్ ఈస్ ద అసైన్మెంట్ ఆఫ్ a set of observations into subsets, so that all observations alike ఒక రకంగా ఉన్నటువంటి అబ్జర్వేషన్స్ అన్ని ఒక క్లస్టర్ లో ఉంటాయి. సో ఇంకొక అంటే ఒక సెట్ ఆఫ్ అబ్జర్వేషన్స్ ఇస్తే అవన్నీ సబ్సెట్స్ గా చేసే పని క్లస్టర్ అనాలిసిస్. బట్ హైరార్కికల్ క్లస్టరింగ్ క్రియేట్స్ ఏ హైరార్కీ ఆఫ్ క్లస్టర్స్ which may be represented in a tree structure called as dendrogram. అంటే ఈ క్లస్టర్స్ లో కూడా వీటిల్ని కూడా we are giving hierarchy, my dear friends. Hierarchy means this is something like this. This is first cluster. This gives you two more clusters, and this is called a clustering tree. This type of tree is called a clustering tree. This is called clustering tree, and this is how it is. The root of tree consists of single cluster containing all observations. This contains all observations, all. Now, these all observations are divided into two parts. See here, observations alike. Konni parts lo like ga unde observations ikkada rastam. In some other cases they are equal అనేవి ఇక్కడ రాసుకుంటాం. ఇట్లా డివైడ్ చేసుకుంటూ వెళ్తే such type of tree is called clustering tree, right? And the leaves correspond to individual observations. Leaves individual observation. This individual observation also, single observations. Individual antaga you can divide the clusters. The basic difference between tree and cluster tree is that leaf nodes in a cluster tree are linked to numerical profiles. Because they represent the individual item. No clusters no individuality, because alike clusters are grouped into clusters, my dear friends. Alike oka rakamga unde anni oka chota untayi. But here ఏమవుతుందంటే no, the ultimate leaf represents the numerical profile. In other words, trees are bounded to numerical arrays. So this is clustering trees, my dear friends. Konchu logical, right? The simple kind of regression tree is considered here also suggests a way to learn clustering trees. This is perhaps, since regression is a supervised learning problem, while clustering is unsupervised problem. The key insight is that regression trees find instance space segments whose target values are tightly clustered around the mean value in the segment. See, tightly clustered around the mean value in the segment. Indeed, the variance of a set of target values is simply the average squared Euclidean distance to the mean. So, in this particular case, see, the variance of a set of target values is simply the average squared Euclidean distance to the mean. So, an immediate generalization is to use a vector of target values. Yes, this doesn't change the mathematics in an essential way. So, for example, you can see here, we can introduce a function, abstract function. This is x cross x belongs to R. That means that measures the distance or dissimilarity of any two instances. Dissimilarity of any two instances, x comma x dash, where x belongs to x, such that the higher this is, higher x key x dash madhyalo dissimilarity. The distance is here, the dissimilarity. X and x dash is less similar, x and x dash. The higher the distance is, the less similar the x and x dash are. Less similar. See, we are talking about similarity. Now, if the distance is high, we can say definitely x and x dash are almost not similar. And this, we are representing this as less similar. The cluster dissimilarity of a set of instances D is then calculated as distance D is equal to 1 by D square sigma x belongs to D. See here, x belongs to D. We have to take a pair, my dear friends, here. X dash belongs to D, and this distance between x and x dash. Distance between x and x dash. See, we can see here. For example, the weighted average cluster dissimilarity over all the children of the split gives the split dissimilarity. See, you can even calculate the weighted average. So that gives you the split dissimilarity. For example, if you consider model A100 B3, what are the relevant positions there? See, A100, if you see A100, What is A100? It is 3, A100 6 and 8. So we are here writing that as 368. See, 1 is B3, 9 is E12, 5 is M102, and T202, see here, T202, 2, T2022, T2024, and T2027. So we have taken the positions here. Now 247,195, something like this. Similarly, condition excellent, good, fair. Wherever excellent is there, in whichever condition excellent is there, we are writing 1, 6. That is, first row there is an excellent, sixth row there is an excellent. Similarly, 3, 4, 5, 8 means 3. In third row there is a good, fourth row the good, fifth row good, eighth row is also good. Second row is fair, seventh row is fair, ninth row is fair. Less like. Similarly, yes, no. 2, 5, 8 are having yes. 1, 3, 4, 6, 7, 9 are having no. The cluster dissimilarity among transaction 3, 6, 8 is 1 by 3 square, because there are 3, into 0 plus 1 plus 2, that is 3, 6. This is the combination of 3, 6. 3, 6. Similarly, 3, 8 and 6, 8. So all combination, all pairs, you have to take all pairs and calculate the distance so that it comes to 0.89. And among the transactions 247, see 247, it is calculated like this, 0.22. So now the other, right, now we have to calculate the weighted average. See, weighted average is calculated as 3 by 9. Total is 9. 3 by 9 into 0.89. 1 by 9 into 0. 1 by 9 into 0. Because say this is 1 by 9. Similarly, this is 1 by 9. And this is 1 by 9. And this is 247. 3 by 9 into, we calculated 0.22. 0.22. Total gives you 0.37. Similarly, in the same way, we can calculate for the second split. Similar calculations, dissimilarity of 2 by 9 into 1.5. So this is 2 by 9, this is 4 by 9, and this is 3 by 9 into, see, if you calculate all these things, it comes to 0.86. Similarly, if you can't calculate the third split, it comes to 2.89. This is, my dear friends, this is dissimilarity. The modal feature thus captures most of the given dissimilarities, while the less lie feature is virtually unrelated. See, this is how the modal feature thus captures most of the given dissimilarities. Most of the given dissimilarities. Now, right now, so smaller, what are the observations now? The smaller cluster tend to have lower dissimilarities, and so it is easy to overfit. Overfit chances are high. How should the leaves of the cluster tree be labeled? See, now what we assume what we say is all the leaves are the individual entries. So it makes sense to label a cluster with its most representative instance. Instead of giving the actual adi most representative instance. For example, we can define the instance as most representative. Most representative if its total dissimilarity to other instances is the lowest. This is defined as the medoid in chapter 8. So chapter 8 lo vachinappudu chadukunnam. For instance, in the A100 cluster transaction, we have 368 A100 300. So in 368, if you consider 368, 6 is the most representative because its dissimilarity to 3 and 8 is 1, whereas the dissimilarity between 3 and 8 is 2. So we can name this label as 6. 6. So this is how, likewise, for 202 transaction, 7 is the most representative. However, there is no reason why this should always be uniquely defined. So this is the problem with clustering trees. We will see in chapter 8. What is that we can do, right? And similarly, the conclusion, Euclidean distances derived from numerical feature simplify calculations, because both the mean and average square distance to the mean can be calculated in order of d steps rather than order of d square required here. So if all we have a dissimilarity matrix, in fact, the average squared Euclidean distance is simply the sum of all the variance of the individual features. So Euclidean distance derived from numerical features simplifies our calculations. So this is modal clustering tree, my dear friends. Modal clustering tree, you can see here, modal clustering tree. So hope you understood. This is about clustering trees. Thank you. This is the end of